My name is Alex. I'm a program manager for Project Turing effort in the enterprise search space. And today I'm going to talk about Project Turing effort to bring semantic search and machine reading comprehension capabilities to Microsoft Search. But before we do that, when it comes to enterprise search today, I'm not sure about your experiences, but from what we've seen, most users typically can relate to the statement that even today, the search in the enterprise space can still be really time-consuming and really hard, and it's a completely different experience from what you're accustomed to on the web. Here are just a few of the customer testimonials or user testimonials that we collected that describe different challenges of searching for information in the enterprise setting. And as you can see here, among other things, people mention that searching for information can be tedious. You have sometimes to try multiple keyword queries before you could even get a decent set of results. And even if you do get a decent set of results, oftentimes you have to open those documents which can be really long and not really well organized. You have to open them and do another search in each one of them to find that piece of information that you were looking for. So overall, it's not necessarily a great experience as of today. And when it comes to the reasons for that, we believe that this problem is essentially twofold. On the one hand, existing enterprise search engines actually come with a set of fairly significant limitations. For once, they rely on keyword matching techniques which have their limits, and there are things that you just can't do with keyword matching. Next, lack of understanding of query's intent, again, limits what you can do, and that is essentially, this is especially true for natural language queries, which more and more users use today just because they grew accustomed to doing that, either on the web or when interacting with their voice assistants and so on. And finally, again, even if you get to relatively good results of the, a relatively good list of the documents, the challenge then is to extract, to find and extract that piece of information that you've been looking for. And this is something that current enterprise engines can't necessarily do that well. But on the other hand, there is actually a legitimate set of challenges that is part of the enterprise search space. And this set of challenges is different from what we see on the web today. In particular, we see that the link graph is fairly sparse. So not a lot of documents link to other documents. And this is completely different from what we see on the web, where the link graph was actually one of the cornerstones of traditional search algorithms to decide what is authoritative content and what is a good content and what isn't. Next, nobody actually optimizes the documents on the enterprise for search engines. And this is, again, unlike the situation on the web where SEO, search engine optimization, is a thriving multi-billion-dollar industry where people actually pay other people to optimize their documents so that it's easier for the users to find them. And finally, the last challenge here is that most documents in the enterprise space are actually relevant for a relatively limited number of users. So most of them fall into the long tail, and that means that there is not a lot of user engagement data to go with to decide which documents, again, attract users, which documents have good content, and which have content that is less useful. With that said, let's talk about what Project Turing can do in this space. But I'd like to preface that by explaining what exactly Project Turing actually is. So Project Turing is a deep learning effort at Microsoft that spans across multiple products, including Microsoft Search, Bing, Office, Cortana, Azure, and so on and so forth. And the idea is eventually to solve natural language understanding by using generalizable end-to-end deep learning models. So this is what Project Turing in itself is. And then let's go to Project Turing in Bing. So Project Turing in Bing uses deep learning models to provide three essential capabilities that we previously didn't have in the search. The first one of them is semantic understanding, which is the ability to search by concept instead of having to rely on a specific keyword. Next, we have natural language processing, which allows the search engine to decipher the query intent and what the user actually was trying to get out of that query. And finally, we have machine reading comprehension, which is a capability that allows us to extract that piece of information that the user was looking for from the document and show it to the user so that the user doesn't have to go through multiple documents and do additional searches within those documents. And in order to further explain that, let me just show you one example on Bing.com, which is this query, which says, what is the heaviest terrestrial in the world? And as some of you might notice, terrestrial is actually misspelled in this case. So let's take a look at what Bing.com returns for this query. So this is a set of results. I know it's probably a little bit small to see from the back rows, but I'll walk you through that. So first of all, what happens here, using semantic understanding capabilities, Bing.com manages to understand that, first of all, terrestrial is misspelled, so it automatically corrected that mistake and included the relevant documents in the search results. Next, it figured that terrestrial is the same thing here as land animals. So in addition to including documents that directly talk about terrestrials, it also includes the documents that talk about land animals, or one of those documents talks about land mammals, for example, because it judges that those documents would probably be useful for the user. Next, using natural language processing, it understands that the query has a clear question intent, so it renders that answer block that is covered in purple on the screenshot, where it puts the paragraph that might be the most relevant for the user. And finally, using machine reading comprehension capabilities, it actually tries to extract that most relevant paragraph and then within the paragraph to highlight a specific phrase or part of the phrase that is able to answer the question that was part of the query's intent. In this case, it highlights African bush elephant, which is indeed the heaviest terrestrial. So that is an answer to the question. And the user then doesn't have to go into the document and search through the document to find that information. So this is just one example on Bing.com. But now let's get back to the enterprise space and see how the same thing looks like in the enterprise setting. So what we do in the enterprise is that we employ the concept of transfer learning, where we take pre-trained deep learning models that we're trained using the web data, and then we apply them in the enterprise context. And this way, we get exactly the same set of capabilities as the ones that we just reviewed for Bing.com, namely semantic understanding, natural language processing, and machine reading comprehension. And none of those capabilities were previously possible in the enterprise search setting. With that said, let's actually go into the demo and see how it all looks like in reality. So here I have a demo tenant that is set up for a fictional company called Contosa. And I'm going to pretend that I am one of the employees of that company that is looking for a few policy documents, which is a fairly common enterprise search intent. And to begin with, let's say I want to see details on the health plan that my company provides. So I go into Bing and I type health plan. So here's what comes up in Microsoft Search in Bing. We see two results. Both of them have health plan, both in the title and also in the paragraph that Project Turing Enterprise Search extracted. And both of them appear to be relevant. And then under See More, you might have some additional documents. Now, this is just one of the endpoints that we currently have. Another two endpoints that we are serving is SharePoint Online, which is probably where the users, for the most part, go today to do enterprise searches like that, and Office.com. So let me switch tabs and go into SharePoint Online and try to do the same query. OK. So as you can see, we are getting the documents that look pretty much the same. The top two documents are actually the same. And if I expand, you can see that the paragraph and the highlight are, again, exactly the same as what we just saw in Microsoft Search and Bing. So on the back end, this is the same search engine, and the results would be exactly the same. Now, let's try and do another keyword query, but this time look for something different. Let's say I want to see whether Contosa campus actually has any hiking paths that I could go unwind after the work. So I type hiking paths, and I get a document that talks about walking and running trails, which seems pretty relevant because I was looking for hiking paths. But the interesting part about this query is that if you were to open the document and actually look through it, we'll find that nowhere in the document is the concept of hiking mentioned. So what happened here using semantic capabilities, the search engine was able to figure out that hiking paths and trail paths are essentially the same thing, and this is why it's bringing us this document. And again, we can switch back to SharePoint and try to search for the same thing. The results should be exactly the same. So we do get the same document, and let's see if the caption is the same. Yes, the caption, again, is the same, and it also highlights trails here. But this is keyword queries, something that the users are fairly accustomed to using, but at the same time, something that has relatively limited capabilities in terms of searching for complex subjects. Let's say I want to set up a remote office, and I want to see whether or not I can get some sort of reimbursement for the remote office expenses. So I'm going to do a question query this time, which would be, can I get allowance for remote office expenses? Let's see what happens. So as you can see, the UX is slightly different this time because similar to Bing.com, in this case, we have a question query, so natural language processing capabilities managed to detect that, and they are rendering the answer card. And in that answer card, you see the most relevant paragraph. And ideally, the highlight should directly answer the question so that you don't necessarily need to actually open the document and look through the document, which is the case here. So the highlight says $100 per month, which is the maximum sum that Contosa is willing to reimburse for remote office expenses per month. So in this case, you don't even need to necessarily open the document. Let's try another question query. This time, I want to know whether I can use my mobile device at work. And in this case, the document returned, again, it renders the answer card, and the document, the first phrase in the document says that, yes, employees can actually benefit from using cell phones. Again, similar to the hiking pass example, what happens here is mobile device isn't really mentioned in that document. If we were to open the document, we'll see that this is indeed the case, but semantic capabilities allow the search engine to figure out that mobile device and cell phone refer to pretty much the same thing, and that's why it returns this document. We can try to do the same query in SharePoint Online. Let me just copy it to make it a little bit faster. And we get the same document with the same highlight. And the final queries that I want to demonstrate is, again, sports related. Let's see, I want to see whether there is a good place on campus to play soccer with my teammates after work. So I type so a fairly long query, where is the best place to play soccer on campus? And as a result, I get an answer card that says that we have a sports field and gives me the address of that sports field. In this case, this is a general use sports field. It's not necessarily dedicated to soccer, and the document doesn't necessarily mention soccer. But what happens here is, again, semantic capabilities allow it to figure out that soccer is just one of the examples of the sports, and that's why it brings this answer. Let's say I wasn't looking for soccer, though, and instead I put football in the query. And let's see what happens. We still get the same result because, again, it manages to figure out that football and soccer are just two examples of sports in general, and it returns the address of the sports field. And finally, let's say I was in a hurry and I misspelled football badly. And again, we are getting the same document because the model is robust enough to automatically detect that misspelling and still bring up the right document. Notice that here what is happening is it's not offering you as a user to correct your mistake, so it's not a spelling corrector. Instead, even with the misspelling, it still manages to surface the right document. So this is it, demo-wise. Let's switch back to the presentation and to close it up, talk about Turing network capabilities in general, and also the target timeline for us to make this set of features available to the customers. So right now, we are focused on indexing shared content in SharePoint Online. So anything that is shared with 2 people or more in SharePoint Online can be indexed and surfaced by Project Turing Enterprise Search. And we have 3 endpoints. One of them is Bing.com, another one is SharePoint Online. You saw both of them. And the final one is Office.com. Experience on Office.com is pretty similar to SharePoint Online, as I'm sure you know. Project Turing Enterprise Search is also fully compliant. It is able to handle access control list handling, so you don't need to worry about potentially showing the documents that have some privacy considerations or that are restricted to a certain audience, to people who aren't supposed to see them. We are going to filter them out automatically. And finally, there is no work for the admin to set this up. All you need to do is essentially to pull a switch, and Project Turing Enterprise Search would automatically start indexing your content. In terms of the timeline, previously, we've been focused on onboarding Microsoft itself, which is obviously a huge company, so it's a good customer for us, and also working with select few early private preview customers to test everything and develop the experience. But now we are starting a private preview, and on the next slide, there would be a sign-up form that would be open throughout November. If you're interested to participate, I encourage you to fill it out, and then we are going to select several dozen customers and allow them to enter private preview, followed by public preview and general availability sometime in 2020. This is a sign-up form. You could either use the link or the QR code. And also, if you're interested in learning more about Project Turing technology or seeing additional demos or learning about capabilities, please feel free to come to our 45-minute breakout sessions that we have on Wednesday at 9 a.m. That would be led by my colleague. That's it. Thank you so much. Happy to answer any questions afterwards. And please evaluate the session. Thank you.